It's David Turner. I'm from Madison, Wisconsin, so a little ways away. I'm the ambassador for Wislug, which is a lug that's in Wisconsin. And by night, I'm a critical care nurse. Not a programmer by trade. I took some computer science courses back in college, back in the 90s. And I've done programming kind of on the side, so it's not something that's completely new to me, but this is not my day job. And mainly why I'm pointing that out is that I'm going to make mistakes when I'm programming and things like that. It's fine. I'll figure them out. You don't need to correct from the audience. But I want to make this accessible so that if you're not a programmer and you've never touched code before, you can do this. This isn't that hard. The presentation format, we're going to have a quick kind of overview of stuff, and then we're going to get into a live coding demonstration of and basically the process of what it takes to get started with Pybricks. By the end of the presentation, you'll know what Pybricks is. You'll know what you need to get started, and you'll understand basic steps to get Pybricks installed and get started coding on it. So powered up. Kind of where this all started from was I wanted to allow audience members to control a train, but if a train goes too fast around the corner, it goes flying off the track, and that's not ideal, especially when people have real fancy trains and whatnot. So I originally was trying to figure out how to make a mechanical stop on the power functions remote, so they could only turn it up so much, but then they could turn it up and hit a button and it would reset it, and then they could turn it up more, and it wasn't going to work. And then Powered Up came out. And for those who aren't familiar, power functions was what we used to have. It would basically, you'd plug it into a battery and turn it on, and it would run. And there were ways to make it kind of go faster or slower using the old 9-volt train controllers. If you go down and look at GBC, that's what you see. Lego transitioned to this Powered Up standard, which is, having used it now, I actually really like it. It's cool because the hubs, you can program them. Lego has an app, which we'll talk about here in just a second, that you can download on your mobile phone and sit and control stuff. But what sucks is that when you buy a Powered Up thing, you need to have a mobile device to be able to control it and use it, which is not everybody has, and I'm not necessarily a huge fan of that. The train ones do have a remote, so you don't need a mobile device to control the trains at home, but it starts adding all this complexity into it, which has its pluses and minuses. These are the different Powered Up devices. They're more than this, but these are just some examples. There's a Technic hub up there in the corner. I have an example down here. And then there's what's called a City hub, which comes with trains. There's a color distance sensor. There's a remote. And these are all the different motors. And there's even a train motor up here. There's more devices than that. So there's a whole slew of devices that get used. And then here is the code to have a train that you can control via a remote, and and this is using Lego's built-in on the app drag and drop programming. And this is the code that you would use to make the train do whatever I was saying I wanted to. I didn't want it to go too fast, and I didn't want it to go to reverse fast. I said, can I do this with the app? And it's this, but I hate drag and drop. And this is also really hard to share to someone and say, here's the code, you can run it on your own. They would have to open up the app and then look at your thing and copy it over. And it's kind of weird. And maybe it probably is great for kids to kind of get started in coding. Not great when you want to do things that are just a little more complex. Quick note on power. One of the things that's frustrating about Powered Up is that you can't plug it into the wall. You have to use batteries. My solution is, and I can't see this up on Zoom maybe, but is you buy one of these connectors, right? You can get a 9-volt transformer for this, and then you take this and you strip the wires down a little bit. Take the batteries out. And you just attach one to one and one to the other. You have to have a little bit of knowledge about which one goes where. That's another story for another time. But then you take this and you plug it in the wall and it'll run forever. So and this is nice because I do this all the time and I just tape it in there. So it's a non-destructive. I can take this out and then use it as a normal battery device. So that's my quick note on power. I've run things like that for, not forever, but for hours without any issue. I don't have to worry about batteries. Pybricks. Pybricks is a Python-based programming environment for various Lego devices. It works on all the powered-up ones. It also works on some of the Mindstorm. Actually, no, it doesn't work on the original one. It works on a bunch of the different Mindstorm hubs that are out there. It's open source. You can access it at pybricks.com. When we get to the live coding here, we're going to open up that and start playing with it. And the Lego device is reprogrammed to run Python autonomously, so you can put the code on there and code it, and then take your powered-up device somewhere far away from the computer, turn it on, and it'll run. And so it's nice. You don't need a computer connected to it. You basically reprogram the hub to do its own thing, and then it's good. You probably still want a computer nearby in case you have to mess with it, but if you have solid code, it should just run fine. Why use Pybricks? You get more usage out of the powered-up devices. There's all sorts of things you can do. There's functionality that's in the powered-up devices I don't know if you can unlock with the native code programming thing. You learn about coding. Anything that kind of lets you learn more about the world around us, I think is a good thing. I like writing the actual code that's you're typing stuff in. Powerful, it's fun. There's all sorts of things that you can do with it. Here's a video example. I wanted to make the loop coaster interactive, and I wanted to add functionality to make the lift arm work separately from the mechanism makes it go up and down, and I wanted to prep it so when you push the button, everything would work. So just as a refresher here, here's a video I grabbed off the internet this morning of what I'm talking about. The loop coaster, it runs around, comes down to this lift arm, and that lift arm is actuated when the lifting device comes down and pushes it, and then it goes on, and then it goes up and then it starts this process where it goes up. I got upset because I wanted the people to be waiting at the station. And I want, basically, when the kids push the button, that the lift arm drops, it goes on to the lifting mechanism, then it goes through one cycle, and then it stops. That was kind of my goal. Our lug had a carnival collaborative, and this was part of that. And so here is a video of my thing in action. This is an example of why you want to make sure you're using positive values instead of negative ones. That actually, I was doing a presentation, I pulled this up and I didn't realize it was the funny video. Here's the actual video of me running powered up on this loop coaster. I push a button, the remote changes colors, the lift arm drops, and then they go on there, and then the motor for this thing actuates, it lifts them up and up and up and up and up and up, and then they go off and do their loop thing, and then they come down and they stop there. And notice it's come down and they're still waiting to get on and off the roller coaster thing. And this thing is running, and it come around behind, and there's a little color distance sensor there that detects when the lift mechanism has come down, so it's prepped so that when people push the button that it goes again. This was all done with Pybricks. This is what's cool. It lets you be able to add interactivity so the kids could come and they push the button and the loop coaster would run, and then it would be prepped, ready to go for the next kid to come push the button when it was finished with the cycle. There are issues with noise. This kind of thing doesn't work so well at conventions because we have a lot of Bluetooth devices around, and that's an issue that I'm still hoping I can find a solution for, but this works really well for small like library shows where it's just your lug showing. So what is Python? Python's a computer language. It's easy to learn. If you're familiar with computer programming languages, the big thing that I kind of have to keep getting caught on is indentation. They don't use brackets or curly braces or parentheses to kind of denote loops or things that are inside others' iteration of things. They just indent things. So it makes it more readable, but if you're used to putting curly brackets and not necessarily keeping things indented, it makes it a little trickier. ChatGPT. This is something that I actually kind of found out last year. ChatGPT is a great tool for doing this. It actually, in some ways, revolutionizes how easy it is to get into doing Pybricks. And I'll show you, because I haven't actually written anything in Pybricks in over a year. And we're just going to use ChatGPT because I want people who have never coded before to be able to get started here. And ChatGPT is also a great debugging tool. Debugging is when you go through and figure out what's going wrong. All right, so now what we're going to do is we're going to install Pybricks on a Technic hub. We're going to write some code, and we're going to see some basic features of Pybricks here. So Pybricks runs in the browser. I'm using a Mac. I don't know what browsers it'll work on a PC. I'm pretty sure it'll also work on Chrome. On a Mac, you need to have a browser that is able to do low power Bluetooth. So Safari doesn't work. You have to use Chrome. Okay. You go to pybricks.com and you push code and you're ready to go. Okay, so here we are. This is fresh, haven't done anything with it. We're going to take a hub out of the box. It's which, as a side note, I meant to check this morning. These are really cheap on BrickLink, and the motors are really cheap on BrickLink. I bought a whole ton of them. They were like, because if you buy them off the Lego website, they're like $60 or $70 for a hub, and then like the motor's like $20 or $30 or $40 or something like that. If you really want them, I would get a $100 or $150 Technic set. You get a bunch of Technic pieces and you get the hub, or you can go on BrickLink and you can find these, or you could find them. I'm sorry I didn't check today, for like $15 from Europe. It's really bizarre. So I open this thing up. I'm going to put my batteries in. Whoop, take out the old battery carriage. Put new batteries in. And when you turn this on, it's going to flash white. And what that's doing is it's waiting to pair using the native Lego firmware to connect to either, actually, I think these have to, the Technic hubs have to connect to a mobile device. It's running Lego's powered up app. So what we're going to do is we're going to reflash the firmware, which is kind of scary, but I haven't had any issues yet. You come up here, you push the Bluetooth thing, and it'll say, let me use Bluetooth, yes please. And it says, I can't find a hub. We're going to install Pybricks firmware. We're going to do it on a Technic hub. And then it has a license. We go, I agree. We're going to name it Pybricks hub. And there's a video that shows you exactly what you're going to do. And we're going to hit install. And now it's looking for this. What I have to do is I push the button, I hold it down, and it will start flashing purple. And then I click over here to the bootloader, I hit pair, and then this starts doing Christmas colors. I can let go of the button. I found that out about a year after I'd been doing this, and I'd been holding the button down for like a minute, which hurts my fingers. So here it is. It's installing the new firmware. You don't want to take the batteries out at this point. Hopefully you have batteries that are going to last a while, and it's sitting there going through, reflashing the firmware, and then once it's done doing that, we'll be ready to go. So this is, hopefully you've already seen that this is not hard or scary. All right, so here it has the firmware installed. Now it's flashing blue. That means it's ready to find a thing to connect to. We put up here, we connect to our Pybricks hub, and we're ready to go. Okay, I'm building a simple device here. This has 4 different little ports on it, A, B, C, and D. I plug the motor into A, and then I'm going to go over to ChatGPT, and we're going to ask it, please write me a program that will connect to a motor on port A using a Technic hub using Pybricks. All right, and it's going to tell me what I'm supposed to do. Okay, so here's the code. I always try to be polite. It's just I don't think it cares. So here I copy the code. I come over here and I need to make a new program. This is demo A. I can't have spaces. Demo A. And there you can pay and unlock a block programming version, which is what I use to get away from. So I don't want demo B. They have a block programming language, which is why I use Pybricks to get away from that. So I'm not going to start using it. This is free, by the way. You don't have to pay for it. And I paste what I got out of ChatGPT. And then I'm going to hit play here. And there it is running. Not actually, what is this thing? Oh, it said, okay, run forward, wait 2 seconds, then stop, and then go the other way. So there we are. That's all it takes. And now what's fun is that if you've never programmed before, go in here and change these numbers. We'll put in 1,000 and 1,000 and see what happens. It runs faster, and it stops, and it goes backwards slower. So we've basically just unlocked everything that we need to do to get started. And what you can also do is my favorite function in here. So there's the way that these programs are set up is that you basically initialize a bunch of stuff up here, and then you set up what you're going to use, and then you actually have your program. So it's kind of 3 parts. There's a really great documentation over here. We're going to scroll down and look at the functions that we have motors with rotation sensors. And we're going to go down and find, there's a motor.run until stalled, which is really, really cool. Let's see if this works here. Okay, there it goes. So it's spinning around. And now what's cool is this, we could go put this on a GBC module and walk away. Because it's just going to keep running and running and running and running and running until I grab hold of it and I stall it. Oh, and then it stops, which is really cool because you're not going to burn out your motor now. It'll stop. And then there's an endless number of things you can create exceptions so that, oh, if it stops running, then do this. And there's even code in, they have networking so these can talk to each other. So if you have a Mindstorms hub, you could alert the Mindstorms hub to say, make a sound, and you could have it start making sounds and saying this motor stopped. There's an endless amount of things that you can do. But just for a simple, like I want to replace my old power functions GBC stuff that we have a program here and this will run now. And now what's cool is we're gonna disconnect from our hub. The hub now starts flashing because it's lost its partner. But if I push the button, it starts running whatever program you last put on there. And so now we could take this and go, again, plug it into a GBC thing. If we're using my power trick, you could plug it in and it could run all show. So that's kind of the start of our exploration in here. So what we're going to do next is we're going to take a train and we're going to start playing around with some of the other functions here. Before I get any farther, does anyone have any questions at this point?
Oh, yeah. So you've shown a basic hub. Is it as simple if you do an actual Mindstorms brain, say the Inventor system, which is the most recent?
Yes, it's exactly the same. The Inventor system. So, and this is where the documentation is really, really great. And you go down and you click on here and it shows you the different hubs you can install this on, and you click on here and it'll show you the different things that hub can do, because like, for example, the Inventor hub, it has an LED screen. Yep. So this talks about that. That functionality is not on the Technic hub because the Technic hub doesn't have a screen. So you can go through here and it works exactly the same. So this is like really, really cool if you're into this stuff.
Okay, thanks.
Okay. So what we're going to do is we're going to start playing around here. We're going to take our train motor and we're going to see if we can have ChatGPT make short work of this for us. But take a train motor. Let's go back to ChatGPT and say, I have a Technic hub connected to a train motor and a color distance sensor. please, write some code that will stop on the color red. Okay. And so here it is. It's writing the code. And I was like, this is really short. No, there's more to it. And so we're going to copy that and come, and we don't need to see this anymore. We're going to dump it in here. And again, it's initializing the stuff up here. It's setting up the color distance, and it's telling me I got to put it in port B, which is fine. It defines color red as this. I don't quite know enough Python. I kind of understand what's going on here, but I also don't, so I'm trusting it. And then here's where I talk about this indentation. It's basically running a loop. It says while true, it's going to get the color. It's going to print color red. This is something cool when you're hooked up to the computer is you can talk to the computer and you can send it messages to help you debug, to figure out what's going on inside its brain, which you can't see when it's not hooked up to a computer. You don't have to remove that code. It'll just send it out into the ether or something. And then it will stop it here. And then it just keeps going around and around and around. So we're going to take our plug. We're going to plug our motor into port A. We're going to plug our color distance into B. We're going to attach it to the front of the train. I've actually done this. There are holes in the bottom here. You can actually, if you're a little clever, you can put this pointing out the bottom, and so it doesn't need to be sticking out the front really ugly. You can kind of hide it in there. I mean, if you look at the train, you'll see lights on the bottom of the train, so it's not a total surprise what's going on. But you can disguise some of this stuff in there. All right, so now I've built my train here. We need to reconnect to our hub because we disconnected from it. This is where we're about to get into the world of debugging. That works. Because I don't know what's going to happen here. All right, so we're going to hit play. And it's thinking, is it too far away? I hope it's not too far away. Let's try this again. There. Now play. Far away, because it's normally, you can normally be that far away and it doesn't get that upset. Turn this guy on. Oh geez, now I got two of them on. There we go. Oh, good. It ran and it gave us an error, which is kind of what I want. Not always, but let's see. And it said, check cables to motor and sensor. So I'm supposed to have the motor on port A. Oh, you know what? Let's see. This is, okay, so we're going to take this and dump it into ChatGPT. It gave me this error. I already know what it is. We are using a train motor. Did it? Try this. Dump it back here. And it's still upset. and see, it's giving me for B, A. What I think it's upset about is that I don't have the right motor initialized because it really wants it to be a DC motor, and it's smart enough to know that that it's not the right motor. Now, what's really cool is if you go down, there are sample programs. So we're going to see if this works. We're just going to take the sample example program over there and then dump that in here. And this should just, okay. Whoop. So that one's success. But what that tells us is that our train's going too fast. Okay. So let's go, and we're going to tell ChatGPT, initialize the motor like this and see what it does. And then if, oop, geez, come on. Stop. Did it do it right? Okay, this time it did it right. So this is also demonstrating the oh, 1 second, I don't want to do that. Not yet. I feel that programmers are going to turn into software managers. This Bluetooth is having no end of trouble here today. Or actually, I think maybe what happened is that that program got stuck in some weird loop. Let's try it again. We're gonna, oh, it's at 50. We're gonna turn it to 30. I don't want it going any faster than that. Okay, so here's the train running. Run for very long. Oh, because it saw red. Okay. Don't quite know how it saw that, but here it is, trying to make, oh, it's making the corner a little better. And comes around, and it should see the red and stop, and it did. And so, and you can see, we had a couple hiccups there, but we got this working in a rather short amount of time, and I haven't actually done any real coding yet. I've just copied and pasted and talked to ChatGPT. So what we really want to do is, if you wanted to make like a train station, we're going to tell it to wait, here, this is the function for making it wait. We're gonna have it wait 2 seconds. When you're doing things like this, normally don't have it wait too long, even if you're gonna have it in the end result wait for a long time, because then you're waiting and you don't know if it's ever actually doing anything. The wait, it's in milliseconds. And the thing is, if that's an excellent question. What you could ask ChatGPT. I'm going to refer to the documentation here. You go in here and you go look for documentation. You have to learn what's in here and find stuff. What I don't know where wait is in. It's frustrating because I don't remember where to find this. Like the is it? Yeah. Right. It's in the basic tools. It's in the Python tools wait here. and it's a timing tool. It has all this stuff here that's talking about the drag and drop bricks, but here it talks about wait is the function, and it says wait number of milliseconds, how long to wait. And so you can go through and do the search up here and look for the function and find out what the function's actually doing. But here I'm copying to run the DC motor. It's going to wait 2 seconds and then run the DC motor again at 30. So let's do this again here. Here it is going around. And then if you notice down at the bottom where it says program finished, that's its kind of communicating to us to help us debug. And it stops there and it says red color detected, stopping the motor. It's going to wait a second and then it's going to start going again. So let's have it, let's see, we got other colors down there. So we're going to, and this is how I tend to code, is I look at something and I copy it and I paste it and I change the things in there to read what I want, because I learn best by seeing something that's done. I hate reading books and I have 10 minutes. I hate reading books and trying to figure out the code from the book. So I like seeing code, which is, again, great with ChatGPT. Let's see here. We're going to copy this code here. And this is how this isn't the only way to learn, but this is how I learn, and I'm sure other people out there. It's going to say green color detected, and we're going to turn the speed up to 60. I know I don't want to do the corner there, and we're going to wait 1 second and then turn the speed back down. These little hash things, those are comments. You've never, I don't know what people on Zoom are doing. The comments are little things to let you know what's happening. I'm not updating them very good here. And then we hit play, and now it should go around. Oop. It's seeing a lot of green. And also notice that it's seeing a lot of green. It's going past the red and it's not stopping because it's going too fast. So what we could do is go back here. This isn't going to solve our green problem, but we're going to shorten the weight of the loop so that hopefully when it sees the red, it'll stop. Nope. Green color detected. So green was a bad color choice. We're going to change that to blue and see if that works better. Is blue. The one frustrating thing about the color distance sensor is that it will pick up and see things that we don't necessarily see. And then, see, it's still seeing some blue in there. But you can tell because on the bottom there, it keeps saying that it's detecting green. And so we at least know what's going on inside of its head. We can, let's try this. Color this. Put it forward and go back to here and have the motor stop if the distance is less than 8. And this is something you're going to have to play around with if you actually get up. If you're doing this, we don't have time to really talk about it in depth. I just want to show the demo here of how easy this is to do. And okay, good. It's given up on doing color, which is what I didn't want it to try to do color here. All right, so now if this is where I'm putting my life on the line here. If I put my hand in front of it, it should stop. It did stop. It did stop. That's where and the really quick thing that you want to do is what we can do is we can use the print function to print the distance. So we're going to print the distance, and this is where you can start using the oh geez, that's my problem right there, is it's putting it out as 100, and obviously when I put my hand here, number change does get to be less than 10, so I want the distance less than 80. We'll try this again here, and this one I think should work better. The issue there was it was probably going too fast, and it slid to a stop. But I think you saw that it worked kind of like I thought it should. Let's try this one more time. We're slowing our train down. Now it's going a little slower. I'm putting my hand on the other side here. There it stopped. So you could put that on your train so when kids try to grab it off the track, it'll stop. Now let's also, just for the sake of kind of do an example debug, we're going to delete this. This won't work, right? If I try to run it, it'll say something's gone wrong. I'm going to copy this, go back to our friend ChatGPT, and I say, what's wrong with this? And then I paste in that code, and it's going to say, yep, you see, I found the error there. It said, this has a syntax error. So again, if you don't have any experience with Python, you can start by kind of using ChatGPT to like dump stuff in there to help you code. My advice is use it as a tool. Use it as a learning tool to get you started. Don't become overly reliant on it for the long term because that's not fun. But if this also is the only way that you have no interest in learning how to code and you just want a train that will run around and stop when someone puts their hand in front of it, this will do it too. Right? So I'm not at all trying to gatekeep how you're supposed to use this and whatnot. But my advice is this is a fun way to learn how to code, learn more about the world. Use ChatGPT as kind of a tool to get you into it, and once you're in there, then start playing around with stuff. Does anyone have any more questions? Yeah, go ahead.
So if someone wanted to use the blocks to program, would ChatGPT do that, or would it just give this, then you put it in and it converts it to blocks?
I have no idea. That's an excellent question. I think once you start a program as a blocks program, you're stuck in that path. So I don't think that ChatGPT is going to have something that you could dump in there and back and forth. That's a good question. I'd say play around and find out, but I don't think it would.
So when you're in Lego's like mobile app and you have it in block, can you tell it, will you please output this in Pybricks, or you can't?
You can't output because when you're in Lego's app, don't quote me on that, but there's no terminal, there's no console for it to tell you what's going wrong. I haven't used it in a while, so I'm not really a good one to ask about that. But obviously this does, and that, yeah.
So if you copied, let's say you had this in block, and you copied that and pasted it in ChatGPT, does it recognize the block?
I have no idea.
Could it spit out
Pybricks? If I take the text, it will. I don't know what would happen if you took the blocks. You'd have to have the upgraded ChatGPT, and you'd have to take it in and paste it as an image. And whether or not that would work, I don't know. Yeah, I have zero experience with the block part of Pybricks. I've just used the Python part, which is, as I said, and what's cool, our log has a repository that we dump. I have no time left. Can we get one last question in? One last question. We have a depository that you can copy and paste your stuff in there, and then I can look at it and say, this is wrong with it, or someone else can use it to copy and paste it, which is cool about the text. Go ahead.
So why did you move away from the block programming?
Because I like typing stuff in. It's easier for me to look at it and to copy. I mean, a lot of it's a copy and paste is okay, do this, do that. And also the sharing part of it is I can take this and copy it and put it for our lug to see, and then they can copy it and do stuff with it and bring it back. And kind of that to me is the really big appeal. But I just, the way my brain works, I don't like the blocks. Yeah, especially for the blocks that's in Pybricks, there's a lot, but for the Lego stuff, it's like there's almost no documentation. You have to play around and figure out what it is. So, all right. If you have more questions, I'll be outside the room. I love talking about this stuff, so come ask me lots of questions. But other than that, that's the end of our presentation. Hopefully everyone knows what Pybricks is. You see how easy it is to get installed, and you know how to get started. So spread the word. Let people know you're not locked into the Lego powered up ecosystem.